Hey guys, welcome back. This is the part two of the notes for 6-4, so linear versus exponential. I want to make sure that we finish up these last three examples and so you know how to do them. This one has to do with the chart. So they gave us a chart and they want us to come up with the equation down below. But before I can do that, I need to figure out what's going on in the chart. So what we said is if it's linear, it's going to have a pattern that involves addition in the y column or in the f of x column for this case. Or if it's exponential, it'll have a pattern involving multiplication. So if you remember, there was a little trick to this, and I showed you on the previous notes. The first thing is, let's pick two numbers in the chart, okay? I see the 0, then the 1 here, and I see a 1 and then a 2 there. So I like that because usually if it's exponential, then those are probably going to be my A and B's. But if it's linear, then we can figure out something else here. So let's use these two numbers, 1 and 2. And keep in mind, if I subtract 2 and the 1 above it, that'll give me an answer of 1. So what that means is I can come back over here. If this is a linear function, then this thing should be plus 1 to get the next number, which that works for this one, right? Because half plus 1. Oh, maybe that doesn't work. No, that would be 0 plus 1. So no, that doesn't work here. If I do 1 plus 2, yeah, that does work, but it didn't work for the one above. And if I do plus 1 there, that's not going to work either because 1 plus 2 does not give me 4. So having the 1 as my addition pattern doesn't really make sense. Okay, so I'm going to say it's probably going to be exponential then. And let's go ahead and check it with the same two numbers. Let's use the 2 and the 1. And we said if exponential, then that means your b would be the 2 here divided by the number above it, which in this case is the 1. So if I do 2 over 1, divide them out, you'll get an answer of 2. And so if we check this one, then now what that means is I can take that 2 and multiply. So take 2 and multiply 1/2. 2 times a half equals 1. Yep, that works. 2 times 1, yep, there's 2. And 2 times 2, yep, that's a 4. So here we have our winner. B has to be 2. And this did not work, so we know it's not linear. It's got to be exponential. So if anything, I'm going to circle exponential because we found a number that was a multiplier, and we didn't have a number that's addition here. So keep that in mind. That's why this is exponential. Now that I know this is exponential, we know that the equation is going to look like this one. So down below, keep in mind y is the same thing as f of x, so I don't have to do anything there. I can leave that f of x there. A is going to be what we have in our chart as our y-intercept, and I kind of pointed it out earlier that anytime you have a 0 in front, that this right here has to be your y-intercept. So we know that 1 is the y-intercept. 1 is equal to a, and that's also my y-intercept. Okay, so down here I'm going to put 1 parenthesis now, and if you look at it, the b is the number that we came up with over here. So I'm going to leave that one and put the 2 there, and we have a x power. And like I said on the previous notes, because we know this, we checked it. It's a multiplier by 2 and multiplied by 2, and I multiply by 2. That is the correct number that goes in the parentheses, and I don't have to divide the number in front. And plus the number in front is a 1, so I wouldn't divide that anyway. Okay. All right, so here's my equation, and we're done with this example. Okay, let's take a look at the next example. If you see that this one has another table, it's got some fractions in it. So as far as I'm concerned, if I can avoid these two fractions, I will. So I'm going to pick two numbers on my table and pick 1 and 5. and then we'll set this up to see what pattern fits, if this is going to be addition or if this is going to be multiplication. So if I take the 5 and the number above it, and let's subtract those. So 5 minus 1, that should be 4. And I can kind of already see that that's not going to work. So if I were to subtract 4 from the 1 over 25, that's not going to be 1/5. Again, if I minus 4 here, that doesn't work. The only one it works for is if I'm doing, or add 4, excuse me, add 4. The other one it was going to work for is going to be from 1 to 5. So because it doesn't work for everything, this is out. And then we take a look at the other option. The other option is if I have 5 and then divide the number before it, which is a 1. So that means if it's a multiplier of 5, let's see if that works. So if I do 1 over 25 and multiply by 5, kind of hard to tell with that one. So let's get my calculator out. And let's try that. It was 1 over 25. So 1 ABC 25. And if I times that by 5, that gets 1/5, which is the next number. So that does work. And if I do 1/5 times 5, well, that's the same thing as dividing 5 and 5 here. So yeah, that's a 1. And if I times 5 again, 1 times 5, yep, that one works. So it works for every single one of these, which means this has to be the correct number. And it is a multiplier, which means it's not linear. It's going to be exponential. And just like before, we have our number for letter B. Okay. Also, if I'm looking at the table, we said as long as your first number starts with a 0, then that second number has to be your letter A. This is your y-intercept. So again, A is going to equal 1, and 1 is my y-intercept. So we can go ahead and put that one right there. That's 1. Put your parentheses in, and then inside the parentheses, we know this is going to be a 5. And then to the x power. So I guess technically we could just write that as y equals 5 to the x without worrying about having the 1 in front. But if we're using that model, we want to make sure we're doing the same thing. So this is my equation. All right, hopefully this is working for you. And if you take a look at the last one, my guess is this one's probably going to be linear, but let's check it anyway, since the last two were exponential. But who knows? These all could be exponential. So let's pick two numbers. Any of these numbers will work. 0 and 2 could work, or -2 and 0. I kind of want to use these two negative ones just to show you that we can do it with negatives. So that's what I'm doing here. Okay. And so -2 is the number I have here, and the one right above it is -4. So that's why I'm subtracting -2 minus the -4 above it. So remember, if I have a double negative, this becomes a positive. So here is -2 plus 4, or you could say 4 minus 2. Either way, it's still the same answer. We're going to get 2 here. Okay, let's check and see if 2 works. If I were to add 2 to the -4, that's -2. So that does work there. Let's see if it works for the next one. So here's -2 plus 2. Yeah, that's 0. And then 0 plus 2 obviously would be 2. So since this works for all of them, I'd say this is definitely linear. Okay, so this is a linear function. just for giggles, if you did the -2 and put it on top of 4, or -4, that would be 1/2. And so I can see right away that the only one I think that would work for is the first two. -4 divide 1/2, or times 1/2 is -2. But if I do -2 times 1/2, that should be -1. So that doesn't work for the second number. So that's why this one doesn't work. But the top one does. So if you're doing the slope, where it's addition each time, which means we know this number. And like before, look for the number with a 0 in front. If I have a 0 in front, then this number here is my y-intercept. Okay, but the y-intercept on the linear is your letter b. So this is b. And now I have enough information to write the equation. I've got my m, I've got my b. So here is g of x, same thing as y. Put your 2. Don't forget there's an x after that. And then letter b, in this case, is going to be -2. So -2. And this is the correct equation. Okay. Now, for all of these graphs, I mean, if we didn't do it, but for all of these graphs, you could actually take any of these x values in the first column, substitute it into the formula in place of x, and it will give you the correct value for your g of x or y of x. So if I were to plug in -1 here, I should get a -4 there. And just to show that that one does work, let's do it. Here's 2, here's -1, minus the 2. So if I multiply these two, that does give me -2. Don't forget we're in a -2. And that does give me -4, which does make sense because that is the answer here when in -4 or -1. Okay, so, and we could check any of the ones that are in the x column and it will give me the answer in the g of x column. All right. Hopefully this helps, and make sure that you are doing the assignment for 6-4. If you need to, you can always refer back to this video or rewatch any part of it that you want. Please be working on the assignment 6-4, and then afterwards there should be another assignment in Delta Math for you to complete. Have a good day, and I will see you tomorrow.